Hello everyone, welcome back to my channel once again. I hope you all are fine. So let's start once again where we have left. We were doing chapter 1 from class 11. We were doing the exercise of the chapter, and last time we closed our video with 26th question. So this time we are starting with the 27th question. So 27th question of the exercise says that convert the following into basic units. Right, basic units means standard units. So we have to use the standard units. Okay, 28.7 picometer. It has meter in it. Meter is unit of distance. Okay, so distance has a standard unit, that is simply meter. So we convert this particular question, but before that we should know what is pico. Okay, 1 picometer is equal to 10 raised to power negative 12 meter. So pico means 10 raised to power negative 12. So we are just going to multiply this number, which is 28.7, with 10 raised to power negative 12, and the answer will be in the standard units, that is 28.7 into 10 raised to power negative 12 meter. You can convert it into the standard terms, scientific notations also. We are going to shift this decimal towards left hand side. So 2.87 into 10 raised to power negative 11 meter, it becomes the answer. Okay, let's go to the second question. Second question is also in picometers. So let's take that 15.15 picometer. Okay, so once again use the same, that is pico means 10 raised to power negative 12. So multiply this number with 10 raised to power negative 12. Okay, right, once again we are going to convert it into the scientific notation. Okay, which is 1.515 into 10 raised to power negative 11 meter. So it is like this. All right, let's do the third question. Okay, now third question is 25,365 milligram. Over here it is gram. Gram is CGS unit of mass. Okay, but we have to have the standard unit of mass. Standard unit of mass is kilograms. So we have to convert it into kilograms. So first of all, we should establish a relationship between milligram and kilogram, but there is no direct relationship. Okay, sometimes you forget about it. So what we have to do, we have to convert it into grams. Okay, first we are converting 1 milligram into grams. So milli means 10 raised to power negative 3. So 1 milligram is 10 raised to power negative 3 grams. Okay, and 1 gram is equal to 10 raised to power negative 3 kilogram. Okay, so let's use this particular, and 1 milligram will be equal to 10 raised to power negative 6 kilogram. So we are using this relation. The number is 25,365 milligram, and we are taking the number and multiplying it with 10 raised to power 6 negative 6, and that is in kilograms. All right, so now what we have to do, we have to take the decimal, and there is a decimal after 5, and we have to shift it towards this side. Okay, it is going 1 2 3 4, so it becomes 2.5365 multiplied by 10 raised to power 4 multiplied by 10 raised to power negative 6 kilograms. So when we solve it, it becomes 2.3 2.5365 into 10 raised to power negative 2 kilograms. So this is how you are going to convert this particular question. Unit conversion is very important when we are doing certain numericals where anything is given in CGS units or not in the SI units. Then we should know that what is the relationship between these all units. So there we are using these kind of relationships, and then we are converting them into SI units if a numerical needs it. So that's why it is very important. Alright, let's start with another question, that is 28th question. Question states that which one of the following will have largest number of atoms? Okay, so we have to see whether which one will have the largest number of atoms. The number of atoms are related with moles and Avogadro number. So we are going to use that particular question over here. Okay, so we should know that 1 mole of anything, okay, is equal to its molar mass, which should be in grams, and that molar mass is equal to Avogadro's number, which is 6.022 into 10 raised to power 23. Now this can be any atom, any molecule, or any ion also, right? So mostly over here we have been given like gold, sodium, lithium, these are atoms, and chlorine as a gas, Cl2, which is a molecule. Ion is not given. So we are going to use this particular equation. So you should remember this equation or this relationship. Now first question is 1 gram of gold is equal to how much number of atoms? Fine. Okay, now before doing that we should know that what are their molar masses, right? Because this is a very important thing which we are leaving over here. So molar mass of gold is 197 gram. Okay, for sodium it is 23 grams. All right, for lithium it is 7 gram, and there are 2 chlorine atoms. For 1 chlorine atom it is 35.5. For 2 it is going to be 71 gram. All right, so we are going to use these masses. These all are molar masses. Fine. All right, let's do it for gold. So 1 mole of gold is equal to 197 gram per mole, which is the molar mass, and it should have 6.022 into 10 raised to power 23 atoms of gold. But in question we have been given 1 gram. So if 197 gram is equal to 6.022 into 10 raised to power 23, then how much 1 gram is going to be? That is 6.022 into 10 raised to power 23 divided by 197. So that much number of atoms will be there. When we divide 6.022 with 197, it comes out to be 0.03056 approximately. We are going to take that, or you can also do, it is 68 actually, so you can do 7 also into 10 raised to power 23. So we can convert, shift this particular decimal, 3.057 into 10 raised to power, because we are moving it to the 2 decimal to the right hand side. So 2 is minus from 23, that is 21. This much number of atoms of gold will be present in it. So let's do the second question. Second was for sodium. I think 1 gram of sodium was given. Okay, so we should know that 1 mole of sodium is equal to 23 grams of sodium, which has 6.022 into 10 raised to power 23 atoms of sodium. Alright, so 1 gram of sodium will have 6.022 into 10 raised to power 23 divided by 23. This much number of atoms will be present over it. When we divide 6.022 with 23, it comes out to be 0.2618 approximately into 10 raised to power 23. Okay, decimal can be shifted. 2.618 into 10 raised to power 22. So this is more as compared to gold. Okay, right? Let's do the third one. I think 1 gram of lithium was given. Okay, 1 mole of lithium will have 7 gram of lithium, and it will have 6.022 into 10 raised to power 23 atoms of lithium. So 1 gram of lithium will have 6.022 into 10 raised to power 23 divided by 7. When we divide 6.022 with 7, it comes out to be 0.8602 into 10 raised to power 23. Decimal will be shifted towards right hand side. 8.602 into 10 raised to power 22, which is once again more than sodium. Okay, so let's go and solve for chlorine. Fourth one was, we have been given 1 gram of chlorine, right? So 1 mole of chlorine gas is going to be equal to 71 gram of chlorine gas, which has 6.022 into 10 raised to power 23 molecules of chlorine, right? Because chlorine is in the molecular form. So 1 gram will have 6.022 into 10 raised to power 23 divided by 71. When we divide 6.022 with 71, it comes out to be 0.08482 into 10 raised to power 23. We are going to shift decimal to the right hand side. Now you know what we are going to do. 8.482. Okay, decimal is shifted to the 2 decimal points to the right. So obviously 2 is minus from here, into 10 raised to power 21 molecules of chlorine. So this is how you are going to calculate it. Now, if you can see that our question was that which one of the following will have the largest number of atoms. Okay, so we have calculated for everything. We have calculated for gold, we have calculated for sodium, we have calculated for lithium and chlorine. If you can see, we can see over here that lithium will have more. Lithium has the more number of atoms. Then comes the sodium. Then comes your chlorine molecule. And then there is gold. Alright, now we are going to know the next question. Calculate the molarity of a solution of ethanol in water in which mole fraction of ethanol has been given. So what we have been given? We have been given X C2H5OH, which is equal to, how we are calculating it? We are calculating number of moles of ethanol divided by total number of moles, which is number of moles of ethanol plus number of moles of water, because water was the other component over here, and it has been given approximately 0.040, right? This has been given. What we have to find out? We have to find out the molarity of the solution, right? So we can do one thing. We can calculate the number of moles of ethanol from here, because that is what we need. But for that we should know that what is number of moles of water. So they have not given anything else, and they are saying the density of water is 1. So if density of water is 1, then its volume will be equal to the volume of solution. And in case of molarity, we take the volume of solution 1 liter. Okay, so this is volume of solution, and which is going to be equal to volume of water, right? It means ethanol is present over there, but it is present very less. Okay, so density is given 1 grams per milliliter. Okay, and density is also equal to mass per unit volume. Okay, we can calculate the mass. Mass is density into volume. Density is 1, volume is 100, then mass is equal to 100 grams. Whose mass it is? It is mass for water. Why we are calculating the mass for water? Because we have to calculate number of moles of water. Number of moles of water is equal to given mass of water divided by its molar mass. So given mass of water becomes equal to 1000 grams, and molar mass is 18 grams per mole. And when we do it, it comes out to be 55.55. Okay, 5 is going to repeat itself, moles. We can take extra 5 also. And XC2H5OH, which is equal to 0.040. It is number of moles of ethanol divided by number of moles of ethanol plus number of moles of water. Because water is present in excess, we can, remove these number of moles or neglect these number of moles of ethanol, which is a solute, from denominator only. So it becomes number of moles of ethanol divided by number of moles of water. We do not know the number of moles of ethanol, so we have to calculate it. Number of moles of ethanol is going to be equal to mole fraction of ethanol multiplied by number of moles of water. Mole fraction was 0.040 and number of moles of water was 55.55. When we multiply it, it comes out to be 2.222. 2 is going to repeat itself, okay, like this. So this much number of moles of ethanol are present. Our question asked us for molarity. Molarity is equal to number of moles of solute, which is in this case is ethanol, divided by volume of solution, which is over here we have taken 1 liter. So it comes out to be 2.222 divided by 1 liter. You can take moles over here, and that comes out to be 2.222 mole liter inverse or 2.222 molar. So this is how you can calculate the molarity of this particular question. Okay, our next question is, what will be the mass of one carbon 12 atom in grams? Okay, we have been given carbon 12 atoms, right? We have to convert its mass. So we know that 1 mole of carbon 12 atoms will weigh, we have been asked only mass, right? Will weigh 12 gram. Fine. And but number of atoms are also included, so include the Avogadro's number, which is 6.022 into 10 raised to power 23 atoms. So we can say that 6.022 into 10 raised to power 23, okay, carbon 12 atoms weigh. Their weight is 12 gram. Okay, then what will be the mass of one carbon atom? 12 divided by 6.022 into 10 raised to power 23, okay, which comes out to be 1.9927 into 10 raised to power negative 23 grams. So this much mass, this one is the weight of one carbon 12 atom in grams, which is quite small. Okay, so that's all for today. I think I hope you all have understood that how to calculate or to solve these kind of numericals in your future endeavors. And thank you so much. Have a nice day.